So, when you think about the search for aliens, you probably imagine us listening for radio signals, right? But what if the real key isn't to look for life itself, but for its power grid? Today, we're diving into the hunt for one of the most incredible, mind bending signs of extraterrestrial intelligence out there: alien megastructures.
Okay, let's just jump right in with a huge question. How would you even begin to measure a civilization's power on a cosmic scale? I mean, is it about how much territory they control, how big their population is, how advanced their gadgets are? Well, some scientists think the answer is actually way more fundamental.
It turns out the core idea is beautifully simple. A civilization's true level of advancement isn't about any of that other stuff. It's about the sheer, raw amount of energy they can control and use. That's it. It's the ultimate metric. The more power you can harness, the more you can do. And thinking this way completely changes how we search the universe.
All right, so if energy is our new cosmic yardstick, then we need a scale to do the measuring. And that brings us to this idea of a cosmic ladder, a way for scientists to classify these incredibly advanced hypothetical civilizations.
And this is it, the Kardashev scale. It's usually broken down into three main types. First, you have a Type 1 civilization. They've totally mastered their home planet, harnessing every bit of energy available there. Then you get to Type 2, and this is a huge leap. A Type 2 civilization can harness the total energy output of its own star. And a Type 3? Well, they've gone galactic. They're harnessing the power of their entire galaxy. The jump in power between each of these steps is it's staggering to even think about.
So you're probably wondering, where do we fit in on this scale? Well, the answer is pretty humbling. We haven't even made it to the first rung of the ladder yet. Not even close. Some scientists figure it could take us hundreds, maybe even thousands of years just to become a Type 1 civilization. It really puts the whole thing into perspective, doesn't it?
Okay, so for the rest of this explainer, we're going to zero in on that incredible second step, the Type 2 challenge. The mind-boggling leap from harnessing a planet to bottling up an entire star.
I mean, really think about that. How could any civilization possibly capture the entire energy output of its sun? We're not talking about putting a few solar panels on a roof here. The engineering required for something like this is just astronomical, literally. Well, one physicist imagined a solution that is both incredibly elegant and just wildly ambitious. He pictured a civilization building a swarm of giant solar panels to completely surround its sun. You can think of it like building a shell around a light bulb to make sure you capture every single photon of light it gives off. And that giant shell of solar collectors, that is what we call a megastructure. It's a theoretical, planet-sized piece of engineering built for one single, unbelievable purpose: to drink up every last drop of a star's energy. Forget space stations, this thing is basically a stellar engine. Okay, but wait a minute. This brings up a whole new problem, right? If a civilization builds a giant sphere around their star, wouldn't that star just disappear from our view? How on earth do you find something that's been intentionally hidden? Well, this is where we get to the cosmic smoking gun. Let's break this down. From our point of view, yes, the structure would block the star's visible light, so the star would seem to vanish or get really, really dim. But here is the crucial bit, and it's all thanks to a little unavoidable law of physics: thermodynamics. All that energy they're capturing has to be used, and no machine is 100% efficient. Just think about your laptop or your phone. It uses electricity, but it also gets warm, right? That heat is waste energy. Well, in the exact same way, a huge amount of that starlight would be radiated away as waste heat. So while the star goes dark in visible light, the megastructure itself would start to glow brightly in the infrared spectrum.
And that glow is what scientists call an infrared signature. It's the specific pattern of waste heat, infrared light, that a megastructure would be forced to give off. It's a cosmic fingerprint. And it's exactly the kind of thing that our most powerful instruments, like the James Webb Space Telescope, are perfectly built to find. It's the ultimate clue that something massive, artificial, and incredibly power-hungry is out there. So now that we're armed with this clue, what does the actual search look like? It's time to get into the nitty-gritty of the galactic detective work.
The game plan is actually pretty straightforward. Step 1, scan the sky for stars. A lot of them. Step 2, look for any star that shows a really strange, unnatural dimming in its regular light. Step 3, and this is the key, check if that same dim object is kicking out a massive, unexplained amount of infrared heat.
If you find something that checks both boxes, you flag it as a potential megastructure. This is exactly the process that led scientists to study weird objects like Tabby's star, whose light was dimming so bizarrely that a megastructure was seriously considered. Of course, the challenge is always ruling out natural causes, like a giant dust cloud, but that signature is always the first big clue.
And the search doesn't even stop with a single star. The theory takes this even further, all the way to a Type 3 civilization, a society that operates on a level we can barely even wrap our heads around, harnessing the energy of their entire galaxy. Can you just imagine the kind of cosmic heat signature that would leave behind for us to find?
And all of this leads to one final, really profound question. Space is just so incredibly vast, and light takes so long to travel across it. So if we finally detect one of these unmistakable heat signatures, are we actually finding a